Okay, so I got this drill, and don't have a charger for it. Now we have, of course, one battery, and now I have this battery hooked up right this minute to the LabBench power supply. It started off at 2 volts. It's now, this meter is actually pretty accurate despite it being, focus you fuck, despite it being analog. So of course those deviations are like 3/4 of a volt or something, so it is unreadable, but were you able to read it? It's getting close to 20. It is a 20-volt battery. And I have it shifted now into, I call it low gear, but you know, there's the high current and the low current, so this knob adjusts the current. So you see if I crank the current down as low as it goes, and then I shift it into high, yeah, it pegs it. It's more than 1.5 amps, and the needle actually rests on the side of the gauge. So I shift it back into low, and I turn it, you know, as high as it'll go. The potentiometer is dirty, but yeah, you see. But so we're going to soak it like that. I could probably charge it faster than 1/2 amp, but more than 1.5 amps is kind of sketchy, so I would prefer not to. So just to be nice to it. I'm not really worried about the battery exploding. I'm more worried about just damaging it. But anyway, so now we also ended up with some of these, and you'll find that these look very similar. Okay, they're both 20 volt. You know, and obviously one is a DeWalt and one is an off-brand. Now, that's where the similarities end. This is 2012 as the date on the battery. This one I think I read is, yeah, 2020. You can see it there on the right. So these ugly batteries do not plug into the drill. I think just the plastic physically, it mechanically won't do it. Now you could probably cut that down, but since these are from 2012, they're probably pretty rough, in pretty rough shape. And this charger that fit them, with some modifications and some force, I can show you here. This charger also did not fit those guys. So with a little bit of creativity, the resistors are no longer necessary. So what ended up happening was I put the resistors there to fool that little computer circuit board, okay, because this one had a temperature probe, and I measured the resistance of the temperature probe just at ambient, and so I made that quantity of resistors just to trick it into thinking it was connected to the, you know, to the correct battery. But anyway, those pins didn't line up on here. I think this one has, what is that, 5, and this one has 4, you see. So yeah, it just simply doesn't line up. So that's where we managed to hack those out of there. Now the problem was, originally I didn't take this apart. It has the safety Torx where it has the pin in the middle. I don't have any of those. I figured I'd just jam it on there. Well, I think this is a backwards from that. So where this one was positive, this one was negative. So not only was it a short, it was a little bit more than that. It tried to forcefully discharge the batteries backwards into this little wall wart here. And you can actually see, yeah, 8 to 20 volts, 400 milliamps. Would you focus? My God. What is this? The AV channel here? Okay. Now, I actually broke this. So this now, if you plug this in and you measure a voltage, you get nothing out of there. So that cooked. This little red wire here is just a jumper wire. I was just bypassing the portion of the circuit that did the thinking. Anywho, so charging this with the LabBench power supply is kind of a pain in the ass. It's not something that you want to really do regularly. So I was rummaging around, and and you can find any of these, kind of like the one I had in the trash. Obviously this one's 5 volts, it's USB, but you get those little bricks, you have them laying around, you can read the voltage on them. Now 20 is a really weird number. So normally the laptop ones are 18 volts, and I was just curious to see what a laptop power supply would be open circuit. Probably it's a very precise 18 volts under load, 18 volts open circuit. These are very fancy. That's part of the reason that these are so big. It's a very precise power supply, whereas the little bricks, they tend to be less accurate, and they're a slightly higher voltage open circuit, and they're designed to be a slight load gets you the correct voltage. Anyway, this one was unusual. You'll see it's 19 volts. Wow, 4 amps. Jeez Louise. Anyway, normally these are 18. So 19.5 volts is really close to 20. And I measure this, and I think it comes out to, yeah, 19.52, so open circuit. So, ouch. So it may not charge this all the way. The thing that's confusing me is the math. I might do some math real quick. 18 and a half, because this must contain, I presume, 18 and a half, don't forget that now. It must contain these, because if you look at the width, yes, yeah. And so the battery pack is wider than the battery. A little bit hard to see from the camera angle, but this is wider, so you could actually fit these in here. And if you look at it this way, just the shape of that case, boy, doesn't that sure look like that should go in there. So if these are lithium, like cobalt, lithium, ion, as you would probably see it referred to, but the actual chemistry, they're usually either a lithium cobalt or maybe there's another one. Not to be confused with lithium iron phosphate. Okay, so these are lithium iron phosphate batteries. So the lithium iron phosphate is 3.2 volts nominal. The lithium cobalt or the lithium ion 18650s that you're used to are a 3.7. Now, I have not seen a lithium iron phosphate battery in an 18650 configuration. The 18, I think, is millimeter diameter, and then 650 is a 65 millimeter length, and the 0 is nothing. So that's what 18650 stands for. I don't believe they make lithium iron phosphate in this. So if you ever run into one of these, you should almost always expect it to be 3.7 volt lithium cobalt. Okay. Now this, I don't know what that's called, but obviously you notice that's fatter, you see. It's a similar length, a tiny bit longer, but yeah, you notice how much fatter it is. A little hard to tell, sorry. But anyway, those fat batteries can be lithium iron phosphate, but they can also be lithium cobalt. So the only way to know for certain is to actually look at the sticker and read the voltage, because I've seen those big boys that are 3.7, which tells me they're not lithium iron phosphate. I digress. So if we know this contains a bunch of standard 18650s, because of course it does, that's what almost all battery packs contain, is just a bunch of these, unless of course they're a nickel battery pack, and the old nickel cadmium or nickel metal hydride ones contain different cells. They're different size, as you can see. But yeah, no, almost everything, every drill battery that's a lithium basically contains these. So 5 of these, 5 times 3.7 is 18.5 volts, okay, nominal. And that must be why it says 20 volts max, because if we take 18.5 and we add 3.7, that's 22.2 is greater than 20, and this is 20 max. Okay, and what do you charge these at? I think you can charge these at 4.2 volts maximum, is that right? So yeah, 4 volts times 5 is 20. So these are these are 18.5 volt nominal, and 20 volts is probably, they're calling it a 20 max. You notice the max in parentheses. That's a marketing trick, because it's the charging voltage is a maximum of 20 volts, and then they get to advertise this at a higher voltage than it really is. It's an 18.5 volt nominal pack, but they call it a 20 max because it charges at 20 volts. Therefore, and by the way, it doesn't have to charge at 20 volts, but at 20 volts maximum, you could, obviously you want to charge it above 18.5, but maybe 19.5 is satisfactory, but anyway, this is 19.5, and this is 18.5 nominal. I think I'm just going to solder this onto this, and I think I will have myself a charger. And for those of you playing along at home, noticing that the power supply has a maximum current of 4.5 amps, and I was all butthurt about more than 1.5, yeah, you did that math correctly. So here's what we're going to do. We're going to ignore that. I could put like maybe a high current resistor on there or something, but I'm not going to do that, I don't think. Yeah. Because I don't know if I have any really high current resistors laying around, and if it's not a high current resistor, it's just going to burn up. So yeah, we're going to take the lazy route, and we're just going to slap that bitch together. And by the way, 4.5 amps, this is probably, it might even be 5 or 6 amps if you drag it down below 19.5 volts. So yeah, no, this is going to charge, this is going to be the fastest charging battery on the planet about 3 times. And I left the connector on the end, and I didn't cut it off because of course I wanted that wicked blue afterglow on there. Then I took my soldering iron and I just kind of melted all the plastic together. These two seem like a similar melting point plastic, so yeah, I just kind of smush, smush, smush. Focus. Fuck. Yep. All right. So it is plugged in right now. And by the way, that blue LED afterglow comes on even with the thing unplugged because it's just an LED is all it is. So it, you know, it'll power backwards. But anyway, yeah, it's plugged in charging. So my soldering iron's running. I'll let that burn off. And I guess, yeah, we'll find out if it works on the drill longer term than one time.
Yeah, man. There it is. So this is super crazy dangerous. That right there is Balin Mania, and we are going to do something really stupid today. It was a terrible idea. Balin might die. It was making me uncomfortable. Go, Balin!
You riding this?
What the fuck is happening?
Balin said not to talk crap about this camera. It's a piece of shit.
This is so unbelievably sketchy. Why would you put me through this, you jerk?
That's the power of really old engineering.
It'd be nice if it didn't kill me. It's not required.
I felt it fucking pop.
Make a wish, everyone. Make a wish. Not okay. You went too far. This guy, man. This guy.